Our next speaker is Jarod Hutcherson with the Bureau of Reclamation. He's giving a talk entitled Rotary Screw Trap Monitoring of Juvenile Chinook Salmon in the Restoration Area. Jarod has been a biologist with Reclamation since 2010. Since 2012, he's been involved with various projects under the San Joaquin River Restoration Program, including inventory and monitoring surveys to identify fish species presence, absence in all 5 reaches of the restoration area, adult Chinook salmon trap and haul efforts, and fall run and spring run juvenile Chinook salmon monitoring efforts and efficiency evaluations using panel weirs and rotary screw traps. Other notable work outside the San Joaquin includes evaluating side channel enhancement efforts for juvenile salmon production on the Methau River in Washington, evaluating larval fish entrainment at the Tracy Fish Collection Facility in California, and survey efforts to describe side channel connection and potential fish stranding during river flow reductions on the Yakima River in Washington. Let's welcome Jarod, and Jarod, the screen is yours.
Hi, my name's Jarod Hutcherson. As Josh said, I'm a fish biologist with the Bureau of Reclamation. Today I'm going to talk about 3 consecutive sampling seasons of rotary screw trap monitoring for juvenile Chinook salmon in reaches 1 and 2 of the San Joaquin River Restoration Area. These were cooperative efforts with the California Department of Fish and Wildlife. The fisheries framework identifies juvenile salmon migration success as a limiting factor for sustaining spring and fall run Chinook salmon. These efforts were specifically targeted to evaluate spring run Chinook salmon in the restoration area. Monitoring took place each season from fall to late spring and early summer, and the main objectives of these efforts were to estimate production, determine survival and timing of outmigrating salmon, evaluate factors contributing to the aforementioned objectives, and to use the genetic data generated by the Southwest Fisheries Science Center to identify total spawners contributing to juvenile production in the restoration area. As I said, there was 3 sampling seasons of rotary screw trap monitoring that have been completed so far, the 17-18, 18-19, and then the 19-20, though the results from the 19-20 sampling season haven't yet been completed. So the data presented here regarding that specific year should be considered preliminary. The primary components of these efforts were the daily rotary screw trap checks for salmon capture, as well as the water quality characteristics of the river, and secondarily, the efficiency test to determine rotary screw trap efficiency, since traps are not 100% efficient. Let's see here. There we go. Real quick, I'd like to thank Andrew Minks for producing this, as well as the maps on the following slides. This map depicts the rotary screw trap locations shown by the green triangles in reach 1 of the restoration area. San Mateo is not pictured. It was the only rotary screw trap located in reach 2. We had, during the 17-18 year, we had the Friant, the Owl Hollow, and the Highway 99 rotary screw trap. Site selection for rotary screw traps were determined by river access as well as the proximity to spawning areas. Trap placement across sampling seasons was adjusted to optimize locations for trap efficiency and to maximize total fish capture. During the 2018-19 sampling season, the 4 locations were Owl Hollow, Sycamore Island, Highway 99, and San Mateo. San Mateo is shown here in the inset map. Excuse me, the Friant rotary screw trap was removed, or excuse me, it was moved from the 17-18 season and relocated to the Sycamore Island location downstream of the highly influenced mine pit sections. It was also relocated to help evaluate potential predation and migration delays between Owl Hollow and Highway 99. During the 19 and 20 sampling season, locations were similar to the previous season. However, the Sycamore Island screw trap was moved downstream to Scout Island to improve trap access, as well as provide better location for efficiency testing. Okay. So in this image here, the Owl Hollow rotary screw trap is shown as in the upper left image. It's been operated during all years of sampling. The bottom right image is the Friant rotary screw trap, which was only operated during the first year and subsequently moved downstream between Owl Hollow and Highway 99. Traps were placed in the Thalweg near constrictions in the river to maximize cross-sectional sampling of the river column. They were operated continuously and checked daily. Screw traps were checked daily for bycatch, salmon, trap operation, and water quality. Water quality and in-river conditions were used to evaluate factors contributing to migration in the restoration area. Salmon captured were measured for length, weight, and classified to life stage. A tissue sample was also collected via fin clip. During the first 2 years of sampling, all salmon were measured using this process. However, during the 19 and 20 sampling year, due to high catch numbers, salmon were subsampled when numbers exceeded 90 at any one location. Along with the daily rotary screw trap monitoring, efficiency tests were performed every 1 to 2 weeks to evaluate trap operation, since traps do not catch 100% of downstream moving fish. Trap efficiency was then used to predict production under varying environmental conditions and to account for fish growth across the season. Hatchery fish from the Salmon Conservation and Research Facility, the SCARF, were supplied by the California Department of Fish and Wildlife, and efficiency tests commenced once fish were large enough for coated wire tagging. Typically, this was 55 millimeters. However, during the 19 and 20 sampling season, half-size coated wire tags were used to tag smaller fish, which were then we were able to commence efficiency tests earlier in the season when fry were predominantly captured in the river. Fish in each efficiency release group were uniquely marked with a color fin tag to ascribe them to the specific release location and date. Let's see here. All right. After evaluating trap efficiency and receiving genetic analyses from the Southwest Fisheries Science Center, Santa Cruz, the following analyses were completed. We estimated production. We then calculated survival and timing based on either the recapture of efficiency fish or the movement of wild fish from upstream to downstream rotary screw traps. These genetic analyses were paramount in determining run, parental genotypes, and origin, either broodstock progeny or escapement progeny from returning adults. And before discussing the results, I would like to bring your attention to the flows during the 18-19 sampling season. They were higher than typically encountered, and as a result, the Owl Hollow, so you can see here, the Owl Hollow and Sycamore Island rotary screw traps were removed mid-March, just prior to this increasing flow due to safety concerns regarding continued operation, as well as safety concerns regarding trap access. The Highway 99 rotary screw trap was removed late May, concurrent to a second pulse in the system. Therefore, the results should be interpreted with caution, since they are likely biased because of trap inefficiencies due to low capture of both wild and efficiency fish during these periods, and also biased because of the early removal of the rotary screw traps. Okay. So as previously noted, the genetic analyses indicated several cohorts of fish were captured. These analyses indicated both fall and spring run salmon were captured, as well as non-Chinook species. Excuse me. Further, during the 2017 and 18 sampling season, the first progeny from adults returning to the restoration area were captured during rotary screw trap monitoring. So while the first adult was documented during the 2019 season, the first progeny were actually captured during this sampling year, during the first sampling year for spring run Chinook salmon. Adults must have returned under high flow conditions during spring 2017 that permitted bypass upstream of physical barriers in the restoration area. These figures indicate the total fish captured across each of the sampling seasons. Keep in mind, again, the genetic analyses for the 1920 season have not been incorporated, so the bottom two figures indicate all salmon captured regardless of run. And while captured numbers are indicated on the y-axis, the main point of these figures is to show the trends across the sampling years. So typically, large numbers of salmon are captured early in the season at upstream locations. There's typically a mid-season lull sometime in December through February and March. And then later in the season, greater numbers of fish are predominantly captured at the Highway 99 rotary screw trap, and fewer fish are captured upstream. Also of note, in the bottom two figures, both of these indicate the 1920 season, and the one on the bottom right is just a blown up image of that smaller section that's difficult to see in the bottom left image. Of note is that the high numbers of fish captured early on, but proportionately few fish are captured later in the season. Sampling for the 2020 and 2021 year have already started, and capture rates of yearling salmon this season could indicate that fish might be using the yearling life history outmigration strategy versus moving out of the system as smolts. All right, these figures indicate the size of capture across the sampling season. So what we're looking at here in the upper two figures, the yellow squares indicate fall run salmon. The green triangles and the upper right image for the 18-19 sampling season indicate those non-Chinook species that Carlos was talking about earlier. The red diamonds indicate spring run Chinook salmon produced in the river, whereas the blue circles indicate hatchery fish. So those are either efficiency fish that were identified, misidentified as wild fish, or potentially scarf escapees. And again, pending genetic results from the 1920 sampling season, all fish captured, excuse me, are indicated in the bottom figure without distinction. The x-axis here is standardized to November 1st, so it's days from November 1st, just to standardize across the three sampling seasons. And the y-axis is fork length. So along with the previous slide, a key takeaway is that fry are typically captured in abundance early in the season at upstream rotary screw traps, while smolts are generally captured later in the season in greater abundance at downstream rotary screw traps. Few par are captured, and again, there's a definite mid-season lull. This suggests that fry are moving downstream, but then overwintering and rearing downstream of Owl Hollow, perhaps in the mine pit area, for a period before out-migrating as smolts. So the prediction pans indicated here are still preliminary, but suggest that we may be able to differentiate spring run salmon from other runs. In future years, it may not be logistically or financially feasible to do genetic testing on all fish captured. However, consolidating these prediction bands across years may provide a metric to separate runs for future monitoring efforts, though we may not necessarily be able to separate hatchery fish from wild fish. This figure portrays proportional production shown on the left-hand y-axis at Highway 99 over the sampling season, in conjunction with river flows shown on the secondary y-axis. Of note here, a natural pulse coincident with high flows at Dry Creek and an increase in turbidity, followed with higher salmon capture rates at the Highway 99 rotary screw trap. Capture of spring run salmon at the Highway 99 rotary screw trap was brief and occurred over a 2-month period from late March to late May. And compare this with production during the 18-19 sampling season, shown here by the orange bars and dotted line. Any trends were less apparent during the second year of sampling, though higher flows likely had an impact on trap efficiency and capture during these periods. Again, few fish, either wild or efficiency, were captured during high flow periods. And the Highway 99 rotary screw trap was removed late May, so production estimates beyond this period were not possible. Otherwise, estimated production predominantly occurred March through May during similar periods as the 17-18 sampling season. All right. This figure shows extrapolated family group sizes based on maternal genotypes for salmon captured during the 18 and 19 sampling season. Maternal genotypes here are grouped by the associated acoustic tag for each broodstock female. Using rotary screw trap efficiencies and maternal genotypes, we organized captured fish by family groupings. And based on trap efficiency, the family grouping size was extrapolated at each rotary screw trap location in Reach 1. Under the assumption that at least a single progeny from each red was captured in any one of the rotary screw traps, the genetic results should permit identification of the total number of contributing spawners each season. Furthermore, if we can use a combination of data, such as acoustic tags or other methods to ascribe individual adults to specific reds, we may be able to identify factors that contribute to differences in family group size, such as site-specific environmental variables, location in the system, superimposition, etc. This can help identify why each female was successful in producing offspring. Here's some key points that I'd like to close on. Through the genetic analyses, once again, we were able to identify successful spawning and reproduction of returning spring run adults during the 2017-18 sampling season. Capture rates and lack of mid-season capture at locations between Owl Hollow and Highway 99 suggest that mine pit areas may be serving an important function for holding and rearing, as well as the delay of outmigration for juvenile salmon. We did have low capture rates of salmon at our San Mateo rotary screw trap location in Reach 2. During the first 2 years, this was likely from poor or variable trap efficiency. This location was moved upstream for the 2019 and 2020 sampling season, but even with higher and more consistent trap efficiency, capture rates were relatively low, suggesting that we need additional data to evaluate if survival through Reach 2 may be problematic. So we will continue to improve our methods for ensuring safe rotary screw trap operation under a variety of conditions. This may include employing additional rotary screw traps at locations such as Highway 99 during high flows, using different approaches for trap access during high flow periods to ensure employee safety while maintaining operation under such conditions. We will continue to refine efficiency testing protocols to more accurately evaluate trap efficiency and adjust trap operation to maximize capture rates. We will continue to explore using maternal genotypes to identify family groups. This in turn will help estimate downstream migration using fish produced in the river, as opposed to solely relying on hatchery fish. This may also help identify factors contributing to production, survival, and outmigration in the restoration area. With that, I'd like to thank you for your time and I guess open it up to any questions.
Thank you, Jarod. We actually don't have any questions at the moment, but as it is with some of this material, sometimes it takes a little while for it to settle in. So if anybody does have any questions for Jarod after this presentation, you can feel free to reach out to us or to Jarod and ask those directly, and we will ensure that Jarod gets the questions and gets back to you.